Awesome. So good afternoon, and thank you for joining us. I'm here with a panel which would cumulatively probably add to about 100 plus years of experience. The topic or the conversation we want to have is, we've already established that the growth in the data center space is unprecedented. And the question really is, how do you keep up with this growth? And I would like to introduce to you my three panelists here who come from different industries, have different experiences, different profile of customers, and the goal here is for them to share with you their observations and areas where they worked on and what they think about these aspects. So let's begin with a round of introductions. Piotr.
Good afternoon, everyone. My name is Piotr Kowalski. I'm head of innovation of Beyond. Beyond is a Polish data center cloud services and managed services provider. I've been in this industry for 15 years on many different angles. I spent majority of that career on the infrastructure vendor side of things, both coming from the mechanical cooling background, but also working 7 years with prefabrication, which is now, I believe, a great answer to many of the industry needs. And I'm looking forward to having that conversation.
Ronald.
Good afternoon, all. My name is Ronald van der Bos. I'm overseeing all the projects we're doing within North Sea, in Netherlands, but also the other countries we're active in. This means new build data centers, expansions of our 19 data centers we have throughout Europe, but also sustainability projects to make them more sustainable.
Roy.
Good afternoon, I'm Roy Maxwell, ESG and Products Director for Kevlinks. Kevlinks is building future-proof data centers across emerging markets in Europe, but at scale. And my role is to make sure that they are as sustainable as we possibly can be as we grow out our platform.
So clearly the morning has all been about this unprecedented growth, right? And it's non-deniable. There could be hiccups down the road, it could be a bubble, but at the end of the day, we've seen across all bubbles over a 3, 5, 7-year period, this is an upward trend for sure. Given the theme that cloud is still expanding and the growth on the cloud is still very much there, mostly driven by digital transformation journeys across enterprises, across governments all over the world. And now with the new play of AI, I know the earlier panel also talked, in the morning we talked, clearly there is the LLM aspect of the AI, and then there's the inferencing aspect of the AI. But definitely this, the journey has begun. Given this, let me give you an opportunity to share a bit about what do you think is going to be the growth challenge here in this side of the business, more specifically with regards to time and cost to deliver. And if I may ask Ronald, you to expound on that.
Yes, of course. We have a policy or an objective to rapidly grow into the European market. We have smaller data centers, regional data centers, which are smaller, maybe easier to build, but still there are a lot. And what you see is that we have growing demand due to AI or other reasons. And it's very difficult to keep up in terms of availability of power. I think we all know about net congestion in the Netherlands, but it's also getting now in other parts of Europe. Another thing is permitting, because data centers are not the most sexy business in the world, and especially not in the area of municipalities. So that is very difficult. And then second, of course, or third, I have to say, is of course the resources in terms of materials, but also in terms of labor. Are we able to build it in a speed that we need to do? And at the moment, the demand is growing quickly, and the speed of development is maybe a bit lagging down because all the reasons I discussed. I'm not sure, Piotr, if you agree with this?
Yeah, I fully agree, but at the same time, what looks like a challenge from FlapD perspective, I look at it as an opportunity from tier 2 or tier 3 markets, especially now with this new opportunity of AI, which is no longer latency sensitive, that opens the opportunity for land acquisition, power acquisition in completely new locations. The markets are there, the engineers are there, the capabilities of building data centers are there. So it's just looking outside of the usual suspects and finding the new opportunities and new locations, which maybe will also help with actually driving the cost down.
Yeah, and from our perspective, we're looking at building at scale. And you mentioned the large language models, and typically you would expect in Europe when they come, and they haven't really arrived yet, they're going to be at scale over 200 megawatts at least. So that limits kind of where they're going to be. And because they're not latency sensitive, as you said, there's kind of obvious places where they might go. So if we look at that, we're also interested in the inference. The inference needs to be close to the eyeballs. And we're building at scale so that we can deal with different sectors in the market. And that then gives its own challenges around agility, because we're starting to build now. We're building 32 megawatts, and it's air-cooled. But we're building out in phases, thankfully, which means that customer demand, I suspect, will alter over the 18 months that we build. So we need to be able to pivot so we can deliver higher densities through liquid. And that then again brings another challenge, because everybody else is doing the same. So the supply chain is hugely stressed, and the long lead items are the things that are now giving the most stress. It's actually not pouring concrete.
So given that the demand is so strong and there are supply chain constraints and there are supply constraints from an energy land point of view, land more specifically because in many areas the neighborhoods may not want a data center and thereby a constraint, how does that impact cost, Roy?
I think it very much depends where you're looking. So if you're in Amsterdam, then you have a different challenge than, say, if you were looking in a capital city further afield, like Prague or somewhere that is maybe a little bit off the beaten track. And then you have more opportunity to actually gain the power you're looking for. And that happens to be our strategy, so I would say that, wouldn't I? But there are challenges wherever you go. The other thing is, you mentioned the people. And in the past, I would suggest that we've gone to, as a sector, as a business, companies have gone and they haven't considered the people element. We need to do that moving forward. It's a huge part of our focus in how we do that and how we interact with the communities where we land.
You know, in the earlier panel, I was listening carefully, and some of the points they raised were very relevant. And one of them was, is there today a demand for 100% purpose-built AI data centers? And obviously, there is, especially for folks who are developing LLMs. The key drivers obviously are cost of energy and so on. But then there is still an element of AI required almost in every data center that is out there. And so are you seeing today, irrespective whether you're building a 1 megawatt or a 5 or a 10 megawatt, are you creating the necessary flexibility, adaptability in terms of being able to offer a section with 80, 100 kilowatt per cabinet?
I think I can start with that because that's a very interesting topic. Because if you're not operating in hyperscale cloud space, wholesale colocation, you must be flexible. You must be able to accommodate different types of customers, different densities. The industry has been trying to address that obviously for many, many years. I mean, since I've joined the industry in 2009, it's already been discussing the high density solutions. Obviously with innovation, actually there's been a very simple solution on how to manage higher densities, just enclose the hot aisle containment or cold aisle containment, and suddenly 10 kilowatt or 15 kilowatt per rack is no longer an issue, so there was high level of flexibility. But now with much higher densities that we're seeing, even yesterday I was working with an inquiry of 20 racks, 40 kilowatts each, so suddenly within 20 racks we're talking 800 kilowatt. That requires completely different approach. So it requires creating these high density zones, the pods, and providing the technology to be flexible to accommodate different types of applications. I am a big proponent of liquid cooling applications because in my opinion they actually make managing higher densities much simpler than how it was with air. So again, that's something that I see as an opportunity because liquid-cooled application with CDUs, direct-to-chip, or immersion, that's probably a different conversation, will actually make managing these higher densities much easier than it was with air.
You know, I mean, liquid cooling has been there for a while. I recall in the early 90s building some of the data centers for the financial community with mainframes, and it had liquid cooling. Obviously, over the last many years, it has been a constant in the HPC business, high-performance computing business. It's now coming back simply because air is not sufficient to do the job. However, there is a constraint when you talk of liquid cooling in terms of redundancy. With a fan system, air system, you can always have an N+1 and you can run the air through. But if you're liquid to one of the cabinet stops, the cabinet stops. And so there is a lot of innovation that is still required in terms of how do you address these problems. In the morning, I spent some time in sharing my thoughts and experiences on modularity and how modularity principles could be leveraged, especially with regards to the scale and speed at which we want to operate. Not to mention cost is always a key factor. Let me ask you, Ronald, what experiences you have, because you've been working a lot on some of the modular pieces of the data center business, and you've actually developed data centers using modular technology. If you can walk us through.
Yes, we have it even in our objective to build modular, because everybody understands that you have to you not have to invest that much on day one, but you can do your investments growing with your demand. But for us, we also think we can only use this new modules when we need it. So that is also a use of resources that we can use when it's needed, and it enables us to adapt to new technologies if needed. So in our data centers, where we have a strong focus on our clients, we have some clients asking us for immersion cooling or chip cooling, which we just discussed. And of course, that requires a different technology for cooling. As we are building in modules, we are able to adapt this and set a new kind of environmental controls in, because we did not invest it in day one, but do it along the way and keeping up with the demand of our clients and the technology which is changing.
Modularity has been there for a very long time. The principles of modularity probably can be best understood looking at the x86 server. Everything is modular on that server. You can just keep plugging more memory, add more CPUs, add more ports. You could pretty much play with it and keep expanding on it. So the principles have been there. Obviously, it is not as simple when you talk about plugging in large elements of power or large elements of cooling. And now the conversation is moving into plugging in a whole new building, which is fully modular. Also, historically, most of the modular experiences were with containers. I come from Huawei, and part of our telecom experience was building tens of thousands of telecom shelters, which were base stations and all the equipment inside, located all over the world, spread all over different terrains. But these were containers. But now when you build data centers, the first impression is, this is a container. However, the current modular principles have gone much beyond that. Today, you are able to build complete buildings using prefabricated container-looking modules, as we say. So, Piotr, you've been in the industry with me, and you've done a lot of work on this section or this area of prefab. Share with us what more can be done, because when we meet customers, we talk to customers, the first belief is, oh, are you shipping me a container fitted with equipment? And then if you show them, oh, it's actually prefabricated modules that come together, and the next question is, oh, can I use it as a building, or can I maintain it? Is it a different maintenance cycle? Share with us, how you see that.
Well, I had actually the opportunity to spend 7 years exactly in the prefabricated modular data center business and could really see how that industry has evolved from being a very niche industry and also, as you say, like rather one-off projects addressing very specific needs in very specific locations, very often remote, to actually becoming mainstream. Because when we mention modular, when we mention prefabricated, that's actually helping nowadays to address the exact topic of our conversation, to address that high demand. And that's just one way of simplifying the construction process or splitting the workload between on-site and off-site. And what I've seen, and I think nowadays I would probably say that even all the hyperscale operators have already accepted modularity and prefabrication in different forms. I agree with you that normally it would have been a conversation, is it a container? I think we're way past that. I mean, people have gained enough experience to understand that it's not, and that it's actually a way of helping build fast and build at scale. A hybrid model is something that I see in Europe utilized a lot, where part of the data center building, usually the white space, is constructed in traditional methods, while, for example, the power pods, the e-modules or whatever we call them, different vendors, different names, the power train is offsite prefabricated and scaled. Well, what I see as an opportunity here still is push for more standardization, because being on the vendor side of things, I had seen still each of the operators developing their own designs, while in the end they are still delivering capacity to similar end customers. So there's huge opportunity for further standardization. There's no need really to each of the operators have their own unique snowflake of a power module, power skid, or whatever other prefabricated solution. So once we accepted that this could be a much bigger UPS that is actually providing a fully prefabricated power train and standardize that, that gives the opportunity for the vendors to build at higher scale, to lower the cost and actually improve the speed of deployments as well.
And also, especially when you deliver these prefabricated solution sets in a hyperscaler / in a wholesale colocation business, the white space is usually empty. Yeah. It's fitted out by the tenant. So shipping it as a prefab would not make sense simply because you'll be shipping air, through over trucks and shipping freighters. But clearly, if you are in the business of small, medium data centers, which are reasonably fully fitted, it does make sense to build the whole thing prefabricated.
Yeah, but still, we also have a modular design of a data center, which enables us to rapidly deploy with the objective we have in Germany to do so. We're just waiting for the right position at the moment. But then we can start off with an even smaller data center, fitting the demand or the sales funnel we have, and then as Lego blocks, fit it out, but also build out the data center. And if you nowadays walk through a modular data center, which is built in modules, on the inside you do not see the difference between a real data center traditionally built with concrete compared to a data center made of modules. On the outside you see, of course, the repetition of the modules, but it's very, very good inside.
Absolutely. Roy, the conversation always keeps coming back to time and cost. And as someone who is deploying, what problems or what expectations do you have in terms of time and cost, especially that, or rather that would help you to pay more attention to the modular elements?
I think the challenge is that the time issue, it varies. So at the moment, transformers. When we're in the middle of we're just about to start our build, but we placed an order for the powertrain last June. So that gives you an idea of the huge variations that are going on right now. And in terms of cost, that comes back to the choices you make. So you mentioned standardized UPSs. We're standardizing in medium voltage. That gives you another whole challenge. The reason we're doing that is for terms of efficiency and for flexibility around how we move power around our phases. But it means that there's only certain places you can buy it from. Now, that's a choice we've made. But the other kind of flip side of that is, and it comes back to geography, the lead times are different in APAC. So if we had the reach, potentially, to order through APAC, delivered and serviced in Europe, then that all changes. Because the modularity element of that is far greater, it appears to me, in APAC, and has a far bigger impact there already, and that's why you're seeing reduced timescales. And cost, well, it depends how much you buy, really, isn't it? I can't really tell you too much about cost.
No, especially again when you are building most of your building systems in a factory, you get the benefit of the efficiencies of factory production lines. You get the benefit of standardization. You get the benefit of precision and less wastage in terms of quality, and all of that circles back into dollar savings, which is obviously factored into the cost element. Not to mention the risks of the on-site risks, which are typically factored into every project costing sheet, also can be better managed if a lot of that is predictable in terms of its performance. Now, how can we get this level of energy into the campus? We've been talking about megawatts of power. My journeys take me through almost all the continents. I spend close to 150, 180 days on the road globally. And I can tell you that your problems of Amsterdam are very different than problems of Dublin, and very different than of Singapore, very different of Dubai, and so on. But clearly, energy is a constraint today. And it's not just that you need energy, you also want green energy. And Ronald, in terms of keeping up with this energy challenge, how would you, what do you see around, and how do you look at managing this issue?
Yeah, it's also from perspective of the permitting, because a lot of legislation, especially in Europe, is focusing on a higher PUE or higher efficiency of a data center. And especially in Germany, you are more and more obliged to give your heat to the municipality, to distribute it to areas where people are living. So we have a very big data center in the north of Europe, in the Netherlands, with a lot of energy. But of course, you have to distribute this. So the advantage of having mid-scale data centers, and within the North Sea, we're talking about 6, 8, or 10 megawatts, which is already quite some heat to exchange. Within the vicinity of any municipality or area where people are living, we have the ability to distribute it into the living areas. And that is, of course, helping us reducing all kinds of constraints for permitting and kind of things, but certainly also lowering our PUE, because we can label this residual heat from a data center as green energy. So that is catching two birds with one stone.
Let me push you a bit more here. You also have, not so long ago, started to work on bringing some innovation in the form of hydrogen, within your energy play.
Yeah.
Talk to us, share with the audience, your thought process on that.
I will conceal our secret. Now, as we know, in the Netherlands, our gas and natural gas network will be converted into a hydrogen network. So, with the latest expansion of our data center in Groningen, we placed a hydrogen fuel cell, which is operating over there for 500 kW, which is not a very large scale, but we are now in the process of getting acquainted with it, get it more stable, test it, and drive it into our operations. It is scalable so that we can scale up. For our latest development in Eindhoven, in the south of the Netherlands, we know that this gas line is coming later in the period. So in Groningen, it will probably start, although there are now discussions to move it to Den Helder, but that's a different story. So in Eindhoven, we thought, okay, if we want to scale up this hydrogen thing, we have to maybe choose for a different solution. And then we went to gas combustion motors, which can run on natural gas and on hydrogen. So there's a storage for a few hours of hydrogen on site. And when that is depleted, then we change over to natural gas. Of course, we do not want to use it, so the gas provider is not very happy with our contract, but that's its price what we're paying for. We mostly run on hydrogen. And that is also attracting, of course, clients which are working on the Scope 3 carbon neutralization for carbon reductions. And I have to say, this is, of course, very cool to work with, hydrogen, although it is not an off-the-shelf product like we know it from diesel gens. You can order a diesel gen, place it, put the cables on it, a bit of controls, and everybody knows how to operate this. In hydrogen, we are now working with it. We experience difficulties. We experience also the availability. But we have a strong belief that with this, we have the experience to grow further. And we also supporting the market to develop this into this, because we think that hydrogen is really the best option now to have large amounts of storage for backup power facilities. And maybe in the future, starting off in Groningen, with maybe the primary power from hydrogen.
Yeah, in fact, I'm involved in a couple of potential schemes where there's a lot of solar energy available in gigawatts and is being produced. Challenge, obviously, is that you currently don't have any storage mechanism for that energy. So the plan is to put up an ammonia cracker, which will take the renewable energy during the day, convert it into ammonia, and this will be then used to run hydrogen generators, when the energy is not available. I mean, solar radiation is not available. And with this, if this pilot goes through, then the plan is to almost put 2 gigawatts of renewable energy coupled with a hydrogen plant, ammonia/hydrogen plant, and to be able to, provide that power. What's interesting is that this scheme is being developed as a campus for data centers. And so, because as you know, the price point of green energy and ESG requirement is different for different consumers. A household consumer won't pay you a lot for green energy. A data center customer will pay you for green energy. And so this is something that we expect, pilots to be rolled out early next year, and then, if those are successful, clearly on a much bigger scheme. I somehow don't like to use the word green. I like to call it greener, because, that whole green basically points to zero carbon, and there's no such thing as zero carbon, right? I mean, utopia. But the whole idea is to be more greener than where we were yesterday, and so on. Roy, are these green targets that we have set up for 2030 in the region, by countries, are these achievable with the kind of growth where everyone needs to deploy tomorrow? The last thing you can worry about is being green, because there's so much capacity required. How do you read into this?
Yeah, it's a huge challenge. And so you mentioned the extra capacity. NVIDIA's last earning call, they said that in the next 5 years, we're going to have to double capacity. And then you look at our business. So we construct data centers. So the built environment is 40% of the global emissions of carbon. Within that, you have concrete, aluminium, and steel, 23%. Concrete alone, 11% of emissions. So we're building right now, we're building at scale, and we have a huge focus on reducing our emissions. But to give you an idea, we're going to implement reduced emissions, concrete and steel. we'll reduce our emissions and build by 16% by doing that. But the extra cost is less than 0.25% of the entire build. And I was kind of shocked and taken aback at that, about how low it was. And so because of that, I looked into it more. So for every ton of cement that's created, there's a ton of carbon emitted. And so we looked into, well, what can be done about that? And there's people far cleverer than I am already doing this. So there's companies, 2 in the States in particular, one called Carbon Cure. They take the emissions and then they sequester it and they spray it back into the cement as it's being mixed into concrete. So not that that gives you net zero concrete, it doesn't. But it does reduce massively the emissions by 48%. And the challenge with that is trying to get somewhere in Europe that can make this. So the closest is France or in Italy. But it comes back to modularity, funnily enough. Because if you are building in a modular basis, then you're doing that somewhere centrally with all the benefits that you mentioned before. If you could get your construction partners to be using concrete like that across the industry, then all of a sudden we're reducing in leaps and bounds. And it's no surprise you'll find that investors in companies like Carbon Cure are the hyperscalers. They are already doing this. And us, as an industry, we need to be looking at that across the board, everything we do. So we'll take a whole life cycle carbon assessment view of our buildings so that we'll know from first spade in the ground to decommissioning what's our impact. And then the next one we build, we have to make it better. And it's back to that, getting greener. Zero is a huge task.
In fact, I don't know if any of the equity guys, the finance guys are in the audience right now, but it's not only about financing the play of data centers, because that is a finite, limited, narrow play. But if the financing was available to areas of low carbon construction elements that are in some way prevalent across the board, can be used across almost every aspects of construction. Not to mention prefabricated concrete structures in that environment would become low carbon concrete structures and so on, absolutely. To kind of close out the segment, we talked about the demand challenge, we talked about how modularity applies. We are right now on the energy side. Most of the conversation has been on big data centers, even through the morning we've been talking hundreds of megawatts. But again, you heard the previous speakers also talk about, and most of us have very similar opinions, that while the AI journey has begun, the novelty of the AI journey is in the fact that, wow, LLMs are so huge, gargantuan, you have to put hundreds of megawatts of energy. So clearly, that's exciting stuff for people because you will sell hundreds of megawatts of whatever you're selling. But having said that, that is just the back end of it, because you're only developing the LLM. All of those LLMs will have to be inferenced, will have to be embedded in enterprise applications across the board. And that would bring us to all the new form and shape and scale of data centers at the edge. Piotr, before we close out, I want you to spend time and tell us how all of this will apply at the edge, an AI-embedded edge.
Yeah, to be honest, it's a very nice way of closing the conversation because it's actually showing that the topic requires a look at the entire portfolio, from very small to very large. I'm actually currently involved in planning of edge network. And the approach here is that the data center can become a good neighbor and actually become the heat source for the surrounding communities. And this is something that we've seen actually being very well accepted by also the municipalities that are giving the planning permits, but also the district heating companies who are actually really welcoming the heat from data centers. So I'm currently involved in a project that is planning the data center network, edge data center network across Poland with that in mind. So not only being the power consumer, but actually feeding back to the network and feeding back to the community.
Excellent. So we are 10 seconds short of our closing. Thank you very much for sharing your insight and your experiences. Have a great evening, ladies and gentlemen.
Thank
Thank
you.
you all.